A very important concept before starting with doing the hyperparameters with the randomized search CV, which is the next method that we are going to use. So in the previous case that we have done it by hand. We tried to find the number of neighbors and we identify it to be from 1 to 21 and then search and return all of the accuracy results from, providing us around 21 estimates. But this time on the next topic, as we are moving through the hyperparameter tuning topic, so we say that there are different methodologies also, functionalities called the randomized search CV, which can be used on the random forest classifier model, also the logistic regression model. But before starting doing some hyperparameter tuning for the random forest classifier using the randomized search CV, there is a very important concept called the cross-validation, which is also part of our roadmap that we have to learn. Just to go back, which is here, cross-validation. So to summarize or to explain how the cross-validation works. So cross-validation is a statistical method used in machine learning to evaluate the performance of the model and ensure it generalizes very well, or its generalization ability. So it helps to assess how well the model will perform on unseen data by partitioning the data into subsets. As you could see here is the traditional way of how we do. We have splitted our data. If you recall, the training split into 80% out of 100 patient records, you have around 80% goes to the training split, and the rest of the data goes into the test split with 20% only. So the model is trained on training data and evaluated on testing data. On the other hand, as I mentioned, so how does the cross-validation works? It works by partitioning the data into subset and testing the model performance on different combinations of training and testing data. So as you could see here, you have around 21. This is the traditional way, and then it also takes under 20% from different portion of the data and learns on the training data also by 80%, and then it goes next in case if you have 5 folds or 5 for cross validation. You have now on the third part, you have the 20% of the data, but it's not the same data as it was tested here or trained here. So as you could see, the patient data here, it starts taking with the first let's say 80% of the data and then train on the last 20%. But here, as you could see, that it has taken and learned from all of the data, and even the testing data, it was gone through all of the data. So the model is trained on 5 different versions of the training data and evaluated also on 5 different versions of the test data. So the main purpose of cross-validation is to provide more accurate and reliable estimate of the model performance, especially when dealing with a small data set or trying to avoid the overfitting. Overfitting, if you recall that we said that the model is learning too well and it follows very complex algorithms in order to learn, and then it's unable to perform well on unseen data or real world data. So let's again remind ourselves of the key concepts that we have here, which is the overfitting and underfitting. So as we said, the overfitting occurs when a model is too complex and learns the noise and the training data rather than the actual patterns, leading to poor performance on unseen data. On the other hand, we have the underfitting. The underfitting occurs when a model is too simple and cannot capture the underlying patterns in the data, resulting in poor performance on both training and testing data. So cross-validation helps, to mitigate both of these issues by providing and dividing multiple evaluation across different subsets of the data, as you could see that here. Also, an important, concept here, which is the generalization. Generalization, you can consider it's the goal of the machine learning. The goal of the machine learning is to build a model that generalizes well to new unseen data. In our case, cross-validation help us to estimate how well the model generalizes by testing it on data that it wasn't part of the process. So as we mentioned, how it works, it works like, divide the data set into K subsets, which we called it folds. In this case, you have like 5 folds. And then train and test the model multiple times using these folds. So the, the model learns on all of the data itself compared here. It learns only on the 80% and then tests it on the 20%. On the cross-validation, it learns around all of the data and also tests itself by going through all of the data as well. So just to summarize the key benefit of using the cross-validation, as we said that it has a better estimation of the model performance by providing a more reliable estimate of the model performance than simple train test split here in our case, as it uses multiple train and test splits. Also, it reduces the overfitting and the underfitting risks. Like you can see the overfitting or underfitting the data by providing more valid evaluation using the cross-validation. It also helps you doing the model selection. It allows for easier comparison between the models or hyperparameters. Example, choosing the best value for, if you recall the KNN model, it can, provide us the best value for the n neighbors number, for example, in KNN model. And lastly, as I mentioned, the data utilization. So every data point gets used both for training and testing, which maximizes the use of available data, especially important in small data sets. So this is a summary of the cross-validation. We're gonna see how this works on when doing the randomized search CV to find the best parameters for the logistic regression and random forest classifier models.